This problem is an example of finding a point estimate for the population mean and also an interval estimate for the population mean. So we start out with a random sample of 50 cars at a drive-through fast food restaurant, and they ordered food that costs an average of $21.43, and the population standard deviation is $4.86. The first part of the question asks us to state the best point estimate for the mean cost of all the meals at the drive-through. They're asking you to estimate mu, the population mean, and the best point estimate for mu, the population mean, is just to use your sample mean. So we use x bar, which is the sample mean, as the best point estimate for mu, the population mean. So a point estimate is just a one number estimate, and the best way to do that is just to use the sample data that you had. The next part of the question says create a 98% confidence interval estimate for the mean. So rather than just having a one number estimate like you have here, you're going to create an interval estimate, and it's going to have a confidence level of 98% with it. You need to know your sample size. So if you look back up here, the n is 50. I'm going to jot some of this stuff down so we have it. The n is 50. The sample mean was $21.43, and the population standard deviation, which apparently was known from a different study, was $4.86. The 98% confidence level has a z associated with it, and the z that goes with 98% is 2.33. There's an earlier video that explains how to find that. And now what we do is we just put this in the formula. And when we put the numbers in here, it will create the interval that we're estimating mu to be between. I'm going to bring up my calculator. I'm going to type this left side in first. So 2143 minus 2.33, starting a set of parentheses, 4.86 divided by the square root of 50, and I'm ending my parentheses. The left-hand side looks like 19.8. I'm going to call it 83 cents. And then we'll do the right-hand side. And I'm getting $23.03. So $19.83 and $23.03. And we're estimating mu to be between those two amounts. And we're 98% confident that we've captured the true mu in between these two dollar amounts. That means that there's a 2% chance that we've missed it. So if you need to be more confident, you would change your confidence level like to 99, or if you can be less confident, 95, 90, you can change your confidence level. Now, there also is a way to kind of double check this on the calculator. So I'm touching stat, And I'm clicking my right arrow key and moving the cursor over to test. So I'm going to click it twice. And then this is a Z interval that I'm making. It's number 7. It's a confidence interval where we are using Z. So I'm using number 7. I'm going to touch 7. You want your cursor to be on the word stat. So if yours happens to be over here like this, if it's on data, click your right arrow key over to stat and then enter to get it to stay there. You want it dark right here. Then you're going to put your population standard deviation right here. So we're going to type in $4.86. Then you want your sample mean in here, so $21.43. The sample size was 50. And the confidence level is 98. And then come down on the word calculate and hit enter. And then your confidence interval numbers will be up here. Now I rounded mine, but you can see that they would round to the same amount.